Today we'll begin with our discussion about real numbers, which is our first chapter for grade 10. Right. Now, children, you all know about real numbers. Last year we have been introduced to real numbers. Do you remember? Right. The rational and irrational numbers together formed the set of real numbers. And we also said that whatever numbers we know till date, all of them are classified under real numbers. Why? Because each of them had a unique place on the number line. Each number, let it be a rational or irrational, it has its own position on the number line, and hence the number line was also called as a real number line. So we will just continue our discussion about those real numbers. Let me first brief up the chapter for you so you understand what all things we are going to study in this chapter. So real numbers this year is divided into 4 subtopics. The first one is going to be the Euclids division lemma, abbreviated as EDL. Correct. The second subpoint is going to be the fundamental theorem of arithmetic, FTA. Then we'll be studying something more about irrational numbers. Now what more? See children, last year we just said that root 2, root 3, root 5, root 6, root 7, pi, all these numbers are irrational numbers. But why are they irrational? Did we prove them as irrational? No. We just stated that the exact answer cannot be found out, hence the number is irrational. This year we'll prove them, right? So we're going to prove the irrational numbers. It's a very interesting part. You will like that. And the last part, fourth part, which we have already discussed a little bit last year, this year in greater details we will discuss. It is going to be about decimal expansions of real numbers. What happens when the real numbers are expanded? If we try to find out the answers, what kind of answers we are going to get, right? So let me first tell you what is EDL. It's Euclid's division lemma. Lemma is a word which means a procedure, an algorithm, a stepwise procedure. Procedure for what? For division, given by, yes, of course, the mathematician, the great mathematician Euclid, whom we tried to study last year. So division lemma, the division process given by Euclid. And now again, you know that Euclid did not give us any rocket science. He always gave us simple things which we already knew. Just these things were put in correct words. So what did Euclid say? Euclid says that if A and B are any two integers, mind well, I'm speaking about integers, where the integer A is bigger than the integer B, then we get two more integers, Q and R, such that these 4 integers satisfy the condition A is equal to BQ plus R, where R is less than or equal to B, always less than B, not equal to, and greater than or equal to 0. We are going to study about this Euclid's division lemma in details. I am just telling you the first point. The first thing what we are going to study in this chapter is about Euclid's division lemma. When A is divided by B, we get a quotient Q and a remainder R, and you know that dividend is equal to divisor into quotient plus the remainder. Do we know this division fact? Yes, the same fact we are going to now use to find few interesting things, different things, and especially we'll be dealing with the HCFs of 2 integers, 3 integers, and so on. So that is the first part of the chapter, Euclid's division lemma. In the second part, we'll be studying about the FTA, that is fundamental theorem of arithmetic, which says something about the prime factorization. Have you all studied prime factorization in your earlier classes? Yes, we have. So what are the properties of this prime factorization? And using those properties, we'll be studying a few results. So that's the second part. The next part, as I said, yes, proving certain numbers as irrational. This will help us to understand exactly which numbers are rational and which are irrational. And if they are irrational, why are they irrational numbers? Correct? The last part is decimal expansion of real numbers. Again, you know it very well, real numbers are either rational or irrational. And moving ahead, we have also studied rational numbers are either terminating or recurring, whereas irrational numbers are neither terminating nor recurring. So we'll see these four topics in details. Today we are going to start with our first topic, Euclid's division lemma. So very quickly we'll begin with our first part, that is the Euclid's division lemma. Okay, so what did Euclid say? Right, so Euclid said about two integers a and b. Let me take any two. We can take any two integers, right? But for the understanding purpose, right now I'll take small two integers. Okay, let me start with the integers 11 and 5. Okay, you can take any two integers. I'm speaking about integers, positive integers. Okay, again we'll speak about positive. It can be applicable in the case of negative integers, but that is not right now. We are going to deal with positive integers. So 11 and 5, where a is always bigger than b. If I would have written 5 and 11, still 5 and 11, again my 11 would have been a, 5 would have been b, because a has to be bigger than b. That is our first condition, where a bigger than b. Right? So now we are speaking about what? The division lemma. We are speaking about the division algorithm. So if I try to divide 11 by 5, yes, you all know 5 2s are 10, the remainder is 1. And how do you write this division fact? You will write 11 is equal to 5 into 2 plus 1. While dividing 11 by 5, we got two more integers, 2 and 1. Correct? So when a is divided by b, we get q and r, which satisfy the condition a is equal to b into q plus the remainder r. Correct? A is equal to bq plus r. That is our Euclid's division lemma, which we already know. What do we know? You tell me now. What do you know? You know like this. Dividend is equal to divisor into quotient plus the remainder. You know already all these things. Now see what? There is something unique about this. You remember in the introduction I had told you something about r. See what it is. See, we are dividing by 5. Let me continue my division process. Let me take the next number, 12. 12 divided by 5. Very easily, very quickly tell me. 5 2s are 10. The remainder is 2. 13 divided by 5. 5 2s are again 10. Remainder is 3. I cannot divide further, right? So I'm stopping. I can't divide 1 by 5. So we have stopped the division. Cannot divide 2 by 5. Stop the division. Cannot divide 3 by 5. Now what? 14 divided by 5. Again 5 2s are 10. Remainder is 4. 15 divided by 5. What happens now? 5 3s are exactly 15. Remainder is 0. If I would have divided by 10, then it would have been 5 2s are 10. Remainder is 0. So see what happened. Remainder was 0, 1, 2, 3, 4, 0. Next number, 16. Divided by 5. 5 3s are 15. Remainder is 1. 17 divided by 5, 5 3s are 15, remainder is 2. 18 divided by 5, 5 3s are 15, remainder is 3. 19 divided by 5, 5. 19 divided by 5, 5 3s are 15, remainder is 4. 20 divided by 5, 5 4s are 20, remainder is 0. See, that's unique. Remainder can take only 5 values. Why? Because the divisor is 5. Remainder will have only 5 values. Which are those? 0, 1, 2, 3, 4. And that's what we said. Remainder always less than the divisor b. R is always less than the divisor b. R is less than the divisor b in each case, and greater than or equal to 0. R can either be 0 or greater than 0. Remainder is 0 or greater than 0. But every time less than the divisor b. Correct? Right. So the remainder is either 0, 1, 2, 3 or 4. This is what we have checked from 10 to 20. Let me take any number, children, any number. The remainder will be either 0 or 1 or 2 or 3 or 4. There cannot be any other remainder. Such an interesting thing. दूसरा कुठला remainder असूच शकत नाही. Let me check. It's so very interesting. You give me any number of your choice. Yes, you give me any number of your choice. Give fast.
120.
120. So let me take 120 divided by 5. So tell me what? 5 2s are 10. Yes, you're right. 5 2s are 10. Remainder is 2. Carry down 0. 5 4s are 20. Remainder is 0. Means 5 into 24 is 120. It is a simple thing. So what will be 121 now? You tell me. 5 24s are 120. Remainder is 1. For 122, 5 24s are 120. Remainder is 2. For 123, remainder is 3. For 124, remainder will be 4. For 125, 5 2s are 10. Remainder is 2. Bring down 5. 5 5s are 25. Remainder is 0. So 0, 1, 2, 3, 4. Again 0. Let me take a little bit of bigger number for you. This would be the last example in case of 5. We'll very quickly check for some more numbers also to understand. Okay, let me take a little bit of bigger number. Say 1234, or let me make this 51,234. We are dividing by 5. Let me divide by 5. So how do we start the division? 5 ones are 5. Exactly. Remainder is 0. Carry down 1. 1 cannot be divided by 5. 5 zeros are 0. 1. Carry down 2. 5 2s are 10. Remainder is 2. Carry down 3. 5 4s are 20. Remainder is 3. Carry down 4. 5 6s are 30. Remainder is again 4. Again, the next number 51,235, ending with 5 divisible by 5, remainder would be 0. For 36, remainder would be 1, 2, 3, 4. So when you are dividing by 5, you can get only 5 possible remainders: 0, 1, 2, 3, 4. Remainder less than the divisor, greater than or equal to 0. Now what will happen, you tell me, when you divide any number by 6? How many remainders will you get? 6. 0 less than or equal to R less than 6. Wanna check? Very quickly we'll check for 6, and then we'll stop the discussion for A is equal to BQ plus R in this first lecture. So let me start with 12, because it is easy to understand. You can check any bigger number and you will be checking it. Right? Let me check. 6 2s are 12. Remainder is 0. For 13, what happens? You tell me. 6 2s are 12. Remainder is 1. For 14, yes, 6 2s are 12. Remainder is 2. I said there are going to be 6 remainders because the divisor is 6. 15. 6 2s are 12. Remainder is 3. 16. 6 2s are 12. Remainder is 4. 17. 6 2s are 12. Remainder is 5. Will I ever get the remainder as 6 when I am dividing by 6? No, because remainder is always the remainder is less than b. Let me check what happens for 18. Will I get remainder as 6? No. 6 3s are 18. Again the remainder has become 0. For 19, 1, 2, 3, 4, 5. Means when you divide any positive integer by 6, you will get 6 possible cases. Remainder is 0, 1, 2, 3, 4 and 5. A is equal to BQ plus R, where R is always less than B and is always greater than or equal to 0.